Assalamualaikum and good day everyone. Today we are from Group 10 and our group will be presenting on the production of hydrochloric acid by using direct synthesis from H2 and Cl2. Our group consists of 5 members. First is me, Aiman, as a group leader, Kahul as a giver, Sohaljit Singh, Afifah Dayana, and lastly Amni Ashraf. Our feed materials are sodium hydride and water. These are converted into hydrochloric acid, which is an essential chemical in many industries. The production scale is 0.5 million tons per annum, showing the significant demand for HCl in industrial application. The method involves the direct synthesis of hydrogen and chlorine, forming HCl gas with high efficiency and purity. Now, let's move to the process background. The chlor-alkali process is the key industrial method that underpins this production. It involves the electrolysis of sodium chloride solution which produce chlorine, sodium hydroxide, and hydrogen. In our case, chlorine and hydrogen produced from this process serve as the primary raw materials for the direct synthesis of HCl. The reaction is straightforward, combining hydrogen and chlorine in a controlled environment to produce hydrogen chloride gas, which is then absorbed in water to create liquid hydrochloric acid. To summarize, our feed materials NaCl and H2O combined with the chlor-alkali process and direct synthesis method allow us to produce hydrochloric acid efficiently, sustainably, and at industrial scale. Thank you.
Now I will share about safety data sheet. The first one is sodium chloride hazard. Physical hazard, generally non-hazardous in solid form but can cause mirror irritation when handling in large quantity. Health hazard may cause skin or eye irritation on prolonged exposure. Environmental hazard, large amount in water bodies can disrupt ecosystem by increasing salinity. Precaution: avoid inhaling dust. Use appropriate mask if handling large quantity. Wear gloves and goggles to prevent skin and eye contact. Ensure proper ventilation in area where sodium chloride may be generated. Store in a dry, cool place away from moisture and to avoid clumping. Treatment: skin contact. Wash the affected area with soap or water. Eye contact: rinse eyes with clean water for 15 to 20 minutes. Seek medical attention if irritation persists. Inhalation: move to fresh air. Seek medical attention if respiratory irritation continues. Ingestion: drink plenty of water. For excessive ingestion, seek medical advice to prevent dehydration or electrolyte imbalance. Next, water not a hazardous substance or mixture. Precaution: none. Next, sodium hydroxide hazard: corrosive, can cause severe burn to skin, eye, and respiratory system. Exothermic reaction: react with water, releasing here heat that can cause splashing. Environmental hazard: can harm aquatic life if impor- improperly disposed of. Precaution: wear protective gloves, goggles, and clothing. Add NaO to water slowly to prevent splashing. Use in a well-ventilated area. Store in a dry, tightly sealed container away from acid. Treatment: skin contact. Rinse immediately with plenty of water for at least 50 minutes. Seek medical attention for severe burn. Eye contact: flush with water for 15 to 20 minutes and seek immediately medical care. Inhalation: move to fresh air. Seek medical attention if breathing difficulty occur. Ingestion: do not include vomiting. Rinse in mouth with water and seek medical help immediately.
Now, I'm going to continue by explaining safety data sheet of hydrochloric acid. I will explain about the hazard first. Hydrochloric acid is a highly corrosive substance that can cause severe burns and respiratory irritation upon contact or inhalation. It releases toxic fume, including hydrogen chloride gas, which is harmful if inhaled. Additionally, it reacts with metals to produce flammable hydrogen gas, posing a significant reactivity hazard. Next is the precaution step of handling hydrochloric acid. When handling hydrochloric acid, always wear appropriate protective gear, including gloves, goggles, and a face shield to prevent contact contact with the skin and eyes. Use the acid in a fume hood or a well-ventilated area to avoid inhaling harmful fumes. Never add water directly to concentrated hydrochloric acid. Instead, add the acid to water to prevent dangerous splashing or reactions. Store hydrochloric acid in a labeled corrosion-resistant container, keeping it away from bases and metals to avoid hazardous reactions. Continue with treatment steps. In case of skin contact with hydrochloric acid, rinse the affected area thoroughly with water for at least 15 minutes and remove any contaminated clothing. For eye contact, flush the eyes with water for 15 to 20 minutes and seek immediate medical attention. If inhaled, move the person to fresh air, administer oxygen if breathing is difficult, and seek medical help. In case of ingestion, do not induce vomiting. Instead, rinse the mouth, drink water, and seek medical attention promptly. Next compound is hydrogen. Hydrogen is an extremely flammable gas that can burn with a nearly invisible flame and may form explosive mixtures with air. It is stored under pressure and may explode if heated. Additionally, hydrogen can displace oxygen in confined spaces, posing a risk of rapid suffocation. Proper precautions are essential when handling this highly reactive gas. When handling hydrogen, keep it away from heat, hard surfaces, sparks, open flames, and other ignition sources, and ensure no smoking in the area. In the event of leaking gas fire, do not attempt to extinguish it unless the leak can be safely stopped. Instead, eliminate all ignition sources, protect hydrogen from direct sunlight, and store it in a well-ventilated area to minimize risk. Next is ways to treat exposure of hydrogen. If exposed to hydrogen through inhalation, move the individual to fresh air immediately, administer oxygen if necessary, and seek medical help. In the case of fire exposure, use dry chemical powder or carbon dioxide to extinguish small hydrogen fires, but never use water on pressurized hydrogen fires. For large hydrogen leaks or fires that pose an explosion risk, evacuate the area and call emergency services immediately. Chlorine gas is highly toxic and can cause severe respiratory irritation or failure if inhaled. It is corrosive, capable of causing chemical burns to the skin, eyes, and respiratory system. Chlorine reacts violently with many substances such as ammonia and hydrocarbons, producing dangerous byproducts. Additionally, it poses a significant environmental hazard as it is harmful to aquatic life and ecosystems. Chlorine gas also present as an explosive risk as it can form explosive mixture with hydrogen gas. When handling chlorine gas, use it in well-ventilated areas or fume hoods to minimize exposure. Always wear appropriate personal protective equipment, PPE, including gloves, goggles, face shields, and chemical-resistant clothing. Store chlorine in tightly sealed corrosion-resistant containers, keeping it away from heat, sunlight, and incompatible materials. Utilize gas leak detectors and ensure emergency neutralizers are readily available. To prevent physical contact and inhalation, use proper engineering controls and handling tools at all times. In case of inhalation of chlorine gas, move the individual to fresh air immediately. Provide oxygen if necessary and seek medical attention without delay. For skin contact, rinse the affected area thoroughly with water for at least 15 minutes. Remove contaminated clothing and seek medical care. If chlorines come into contact with the eyes, flush them with water for 15 to 20 minutes and obtain medical attention promptly. In the event of ingestion, do not induce vomiting. Rinse the mouth with water and seek immediate medical assistance.
Hello everyone. So today I'll be talking about exaltation. As you can see from the diagram, it illustrates a chemical process sequence that combines electrolysis with a combustion furnace, followed by cooling water operation while showing exact stream entries and departures. In the electrolysis unit, under 1.5 bar pressure at 80 degrees Celsius temperature, it is fed with water and sodium chloride, which is then undergoes electrolysis to generate sodium hydroxide alongside with chlorine gas and hydrogen gas. Moving on to the combustion furnace, which operates at 2400 degrees Celsius under 3 bar pressure, it is fed with chlorine gas and hydrogen, which is then react to form HCl while producing a minimal amount of unreacted gas as a byproduct. Next, the cooling tower, which have a pressure of 1.5 bar and the temperature of 40 degrees Celsius, is fed with the product from the combustion furnace, which operates to lower the gas mixture temperature at stable flow composition for potential water recovery and condensation. The product of this unit is then flowed to the absorption tower. Thank you.
Hello everyone. In absorption column, there are three components enter the absorption column. Hydrogen chloride gas enter the absorption column at 99.68 mole per hour. Chlorine gas enter the absorption column at 0.25 mole per hour. Hydrogen gas enter the absorption column at 0.25 mole per hour. So the absorption column must conducted at pressure of 1.5 bar and temperature of 20 degrees Celsius. There are also liquid water enter the absorption column at 103.33 mole per hour. So there are two effluent, which is effluent gas and effluent liquid, exit at absorption column. After that, the scrubber also conducted at 1.5 bar and temperature of 20 degrees Celsius. They are effluent gas of absorption column as an inlet stream of scrubber, which is hydrogen chloride gas, chlorine gas, and hydrogen gas. They are water liquid enter the scrubber as a second stream of scrubber. So there are also two exit stream in scrubber, which is the liquid and gaseous.